Skips.
Wait,
I know.
is that Omar's? Does he not wear it?
He makes her own music.
You should make instruments. They like pay it together.
Yeah.
They're like vexing. I mean, like your parents are like. No, I mean, it's your parents. His parents are not really good. They don't even do all that. They are. It's so problematic.
Yeah.
What?
Yeah, page 26 in your packet. So, this is our last section before we start our quiz review. The idea behind finding arc length is very similar to the way that we find area using calculus. With area, we divided our sections into small rectangles. But here, we're going to divide a curve into large quantity of really, really small and short segments, find their lengths, and then add them up. So we're going to make the number of line segments approach infinity. And we know that the distance between 2 points is given by that distance formula, right? Square root of x2 sub minus x to 1 squared plus y sub 2 minus y sub 1 squared. So even though we have a curve, right? Let's say you want to find the length of a curve. If we were to zoom in far enough on a curve, eventually that curve looks like a what? Line, right? So it looks like a very, very short line segment, right? If you zoom in far enough. So that's the idea, is that if we break up a curve into infinitely thin or infinitely short segments, you basically are dealing with something that distance formula can handle, right? This formula can handle a straight line segment. So if we add infinitely short line segments together, we total that up, and we're going to eventually get that that length of a curve. So we can approximate the length of a graph function by using n segments whose endpoints are partitioned between a and b. Think of it this way: a equals x of 0, b equals x of n. Okay. So we're starting with, at least right now, it feels like just shorter segments, but it's still not, it's still just an approximation. But as we make the increments smaller and smaller, those approximations will get better and better, and will fit the curve. So if a function y equals f of x represents a smooth continuous curve, so smooth just means differentiable as well, so differentiable and continuous, on the closed interval from a to b, the arc length between a and b is given by this formula. So here, that 1 plus f prime of x squared kind of resembles that distance formula, but it's adapted so that it can adjust to the formula that we want. And the square root also reminds you of distance formula. And then that integral from a to b allows us to essentially add up infinitely thin short line segments. We're finding distance, we're accumulating all the small distances across the entire region. So we use f prime in the formula because of the connection to the infinite number of tangent line segments we are adding together.
But we get a calculator.
Yes, yeah, you get a calculator for this quiz, so you can use it for any of the problems. Now, some problems I'm going to ask you to do no calculator, and that just means that I want to see all your steps. So show me the work. Like I said, if you do not have a calculator, But you can obviously use your calculator to double check anything that you do. Okay, let's try example 1. Okay. So it says find the length of the graph y equals 112 x squared plus 8 to the 3 halves from 1 to 4. We're going to treat y like f of x, and we just have to find f prime. And then our 1 to 4 is just our bounds. So we can just set everything up. But let's just find y prime first. Let's find y prime, and then we can square it and put it into this formula here. So chain rule can help us get there, right? Do some cleanup here. 2's can cancel out. 30 over 12 is 1/4. So x over 4. So there's my f prime. I'm going to insert f prime into my definition and then see what I can do to clean it up. Okay, I'm going to square. Okay, we gotta be careful here, right? Like, I can't just take the square root and square and undo them, right? There's a plus that's preventing us from just making that a clean canceling out. So I have to expand this out first, see what I can do with the 1 before I can do anything with the square root. So I'm going to square the x, the 4, and that radical there.
Distribute.
Yeah, we're gonna distribute. We're gonna treat this like a non-calculator and see how far we can get. Okay. You're right. We'll distribute that x squared over 16 through, and things should clean up a little better here. Okay, the reason I'm doing this is because if I can factor a 1/16 out, that 1/16 can be pulled out of the square roots entirely. X squared. No, sorry. There's still a 16 up top. So the square root of 1/6, now I can pull this out because now there's multiplication here, so that's just 1/4 in front. So let me adapt this here. And this can be factored, right? And now this is fair game. Now I can undo the square root in the square because there's no addition and subtraction that's preventing me from just canceling those out. Now we have something that's a lot more manageable. Okay, so some problems will be calculator, some problems will be non-calculator. We just want to be comfortable with both options. Yes. No, we don't. We're all dealing with principal values. The only time you're gonna have to worry about plus or minus is if you have an equation and you have to take the square root of both sides of an equation, then a plus or minus will show up. Yeah, but if it's just square roots, we just take the principal value. It's always just going to be the positive version. So really, I think in terms of the setup, the main things we have to worry about is finding the derivative, squaring it, and then if it's a calculator question, then that's it. You just have to plug in the calculator once you determine that f prime.
Are units required?
Not unless the problem asks you for it. So that's the case for all AP exam problems. If they don't ask you for units, they can't take points off for it. So okay, so really we're just practicing with this formula for the rest of the period today. Okay, and just seeing different variations of it. Okay, let's look at page 27. So often problems like this will only ask you to set up the integral, but if it's a calculator section, typically they could go further and ask you to use, if it's calculator active, then they can ask you to find the answer. So here, set up an integral that represents the length of the curve of y equals sine x from 0 to pi, and use the calculator to find the value. Okay, try that. Find the derivative first, and then from there you can insert into your arc length formula. Make sure you're in radian mode. Any questions with 2? Okay, we'll skip the proof. The proof just basically connects the distance formula to the arc length formula. But I think we just have to memorize the arc length formula, but just understand that it's coming from the distance formula to arrive to the one that we want to use. Okay, so now try the practice problem. Try number one. Number one is just asking you for the setup. Okay, page 28. Okay, length of a curve is given by this formula, arc length here. If the 0.16 is on the curve, which of the following could be the equation for this curve? So basically, we just have to kind of work backwards to find f of x. So we know that f prime of x squared is represented by 4x squared. Which means that f of x must be what? Right, I just take the square root of both sides. Would be,
That'd be
oh, sorry, my bad. Yeah, sorry, f prime, my bad. Yeah, f prime of x is equal to 2x. Now, technically, it could be 2x or negative 2x, but looks like by the way that it's our answer choice is given, and it's also order pair 1/6, so that's probably going to still be positive. So if my f prime is 2x, how can I get to f of x?
integrated.
Yeah, integrated. Two x becomes c. And that's where that 1/6 is coming in. It's going to help us find that c value. Okay, try 3, and I'll work through it once you guys have a chance to try it. second theorem, G prime is sine of X, and now we just put into our Parkman formula. Oops, sorry, can't drop the square root here. Okay, number 4, no calculator, so I want to do everything by hand here. Okay, so once you get to part C, then you'll do use substitution. Finish off the problem from there.
Three halves, that's 5 cubed.
Well, I took the square roots first. And then I left the cube there.
If you were to square 5 cube back, it would be 25 and 6.
So. 25 square root. I can do this first before I involve that 3. It just makes it easier, especially without a calculator. Okay. Right. Well, that's sort of treating this like a non-calculator, so we want to be able to get down to it. Now, okay, technically, if those 3 response, you can leave your answer in this form and get full credit as well. But, you know, let's just say it was like a multiple choice question with it all the way down here. You want to fit down here. Okay, anybody still need to look at number 4?
Straight 5 cubed is 125.
Yeah, 5 cubed is 125.
Okay.
Yes, by factor of 2 ninths out.
Okay, I see this.
Oh, I got that one.
Right, thanks. That makes
Okay,
sense.
let's look at number 5. So it says, consider a region bounded by the graph x squared minus 4 and y equals 5. So I'm just gonna freehand what this graph, what this region could look like. X squared minus 4 is a parabola. Y equals 5 is a horizontal line. So basically trying to figure out what is the perimeter of this region. Now, this is a straight line here. I think if we can find the intersection, we can just count that distance and not have to go through any formulas. But this one, we can find that length by using arc length formula, right? So just treat it like 2 separate formulas or 2 separate combinations. We can get that through arc length and get this through adding or just figuring out the distance between them. So I'm going to find the intersection so I can. So this one has an x value of -3, and then an x value of +3. So this should be easy, right? What's the distance from here to here? 6, right? So that we don't have to worry about any formula. Just have to figure out what is the distance using arc length for this curved region. I mean, if you wanted to, you can do an arc length formula for this, and that would still get you 6. Your f prime for this will be 0. Square root of 1 plus 0 squared from -3 to 3. Arc length can still work if you're dealing with a horizontal line. Okay. All right, so let's spend about the next 10 minutes or so, see how much we can get through with the remaining practice classwork problems. So go ahead and start number 6. I think all of these are going to be calculator active, so as long as you find f prime, you can just stick it into the arc length formula, either leave that alone if it's asking for just a setup. If it's asking for the decimal value, you can plug that into the calculator. Okay. All right, so try those. there's 8, 9, 10. Okay, so your homework, check your calendar. And then this is our last section. Tomorrow we'll start our quiz review, and I have a quiz review packet for us so that we can get through between tomorrow and next Wednesday. Right. Folks?
If I don't solve the square, is that fine? If I leave it.
That's fine too, that's fine.
Okay, hypothetically, if I like actually solve it, right, like, I still get credit for this because. What's called?
It says refine the expression for the length,
Yeah, I
so
know.
I guess I wouldn't, yeah. I'll be fine.
Whiteboard.
Huh?
You think whiteboard?
Um,
I didn't know that was right.
I feel like if you see that problem on the AP exam, it'll be a multiple choice, so you'll be able to tell. Yeah.
Sure, Roberto.
Okay.
Okay.
Appreciate it. Thanks, Ken. I'll plug it down.
Like, I think, you don't have it, and we need three other people, we had a week to make it. And
So with this, it was evaluating different tools, but it's not the exact same interval. It's from 0 to 1, 1 over x, dx, and like 1 according to the approach is the other one negative 30.
like, we put the, like, the boards.
It's a different, like.
And then we had the AI.
So this is, so this goes to negative 3, right? Yeah, yeah. And so, but there's a negative outside, so do these, like, make it so that, because here,
It's a bit more complicated.
We don't have to worry about where it diverges, just say it diverges.
okay.
Yeah, don't worry about always infinity.
That's
One of those two, that's enough.
That's like.
So, like, no,
I was thinking about like, oh.
You find someone local.
Yeah.
Oh, yeah.
The one got carried, but I can.
Yeah.
So.
for the other key,
Very generic.
so,
So. Will not be the two.
I was thinking.
Also some other projects. Like one of them was.
Okay, so this one, we had to kind of like work with the actual equation, which I'm not gonna put on the equation.
Oh, no, oh, yeah, the thing was just like, can I tell that,
Oh, that's true. If you figure out 50 just by figuring it out, you're right, you don't have to go through all this.
Okay.
Yeah, yeah.
I didn't even.
that was like one that where you put M or L, it was a formula.
Like saying learning. Yeah.
No, you made.
Yeah, yeah, there are two.
M or L were interchangeable, and I didn't know. If I- I'm gonna find it.
So your question is, how do we get from one to the other without summarizing?
No, it was. I'll find it, I'll find it. So like the formula was written twice, but it had M in one and L in the other. So
Oh, okay, yeah, show that to me. Maybe it's the same thing.